As you saw in the previous clip, that was a demo of my image locking system, which I use Python for. So I'll be explaining that into 17 parts, which is going to be brief. So I'm not going to go into full detail of things. So it's going to be very vague, and you're going to have some Python knowledge to actually understand it. But it's completely okay if you don't. And that's why if you have any questions or any confusions, you can always comment in the comment section down below. I will read them and I will answer them as soon as possible. And if I have the time and I see that most people are having the same questions and concerns, I will make a separate video on it just to address them and explain them. So let's start with the actual thing. So let's start with the first part, which is going to be importing the libraries. So first, I imported two libraries, OpenCV, which allows me to access the camera and process images, while NumPy allows me to create and manipulate arrays, which I use to define the color range and image processing kernels. So basically, these two libraries are extremely important for your code to actually work. And if you don't do them, the code's not going to work because obviously we need to access the actual camera. And that's where this part comes in, where it's this line, which is extremely important because it's actually accessing your camera. So next, I actually access the computer's camera vision using OpenCV. And you might be wondering what this zero means. This zero basically is just saying to only access your default camera, and that's basically what the zero means. So just make sure you have a default camera on your code, or you can also change it based on other settings that you have. So then we have capturing video frames. So this is this section right here. So basically the program continuously captures individual frames from the camera. Each frame is treated as an image, allowing the program to analyze the video in real time. So as I said, the camera is going to be at, or OpenCV is going to be looking at these images, and you could really think of it as taking multiple pictures of that video and interpreting every single picture at a very fast rate and giving it to you in a video format. But it's basically looking at each image and detecting the object and then moving on. So it's easier for the computer to do so. Fourthly, we have converting the image to HSV. So right here in this section, so that's line 15, I convert the image from BGR to HSV color space. HSV makes it much more easier to identify a specific color because hue set represents the actual color, while saturation value describes the intensity and brightness. So if you got a little confused there, HSV is just the acronym for hue, saturation, and value. And as I said in the explanation, that hue is basically going to be what represents the actual color, what's going to be actually showing. So what defines orange, and saturation value is just basically saying your brightness. So if it's, yeah, you get it. HSV. So that's hue, saturation, and value. So now this part, which is extremely important, and you need to, I would say, follow this exact HSV format, but you can always change it to widen your range. So let me explain real quick. So right here, I define the lower and upper HSV boundaries for orange. Any pixel whose HSV values fall between these two ranges can potentially be identified as orange. So that's basically what it's saying. So these three numbers are actually HSV values, and what my program is doing is it's looking at those orange. So let's say you have an orange box. It's gonna be looking at that orange box and thinking, okay, is this in my range of my lower and upper orange? So lower orange basically what's the lowest point where I can identify something as orange, and what is the maximum point where I can identify something as orange? So basically your maximum minimum values. So right there is going to be seeing, does this fall into my criteria? And if so, it's going to be identifying it as orange. And if not, it's not going to be detecting that and thus not walking onto it. So now we have creating the actual mask, which is line 21. This in-range function is not really used a lot, but the in-range function creates a binary mask. It's really used in our camera projects, but basically, as I was saying, the in-range function creates a binary mask. Orange pixels become white, while pixels outside the defined orange range become black. This allows the program to isolate the object from the rest of the image. So I think it might have been confusing at first. Sorry, my script might have been typed out confusingly, but the in-range function creates a binary mask. So binary basically means on off, right? So what it's saying is that on off can also be represented as black white. So whatever's not orange in that sense. Whatever's not orange will be displayed as black, and whatever is orange is going to be displayed as white. So that's how mask works. It's basically making the computer like it's much more easier for the computer to understand those formats in a mask. It's saying, as I said, it's binary, so it's black or white. Black equals orange, black equals no orange, and white equals orange in a simple sense. So finally, it's not finally, sorry, in the seventh part, we have removing the actual noise, which is 24 to 26. Um, Basically, the camera can detect a small unwanted areas of noise, so I use morphological operations to clean up the mask. As I said, this is going to be a little confusing to people who are absolute beginners at Python. Just comment below and I will make a little explanation video if necessary. So as I said, it's using morphological operations to clean up the mask. The opening operation removes small noise, while dilation expands the remaining detected areas and makes the object much more easier to understand. So, in that sense, noise is not what you hear. Noise is basically what's unwanted things. So, if I have a room of like a lot of like inconsistency, that's basically noise. So the computer detects those things and remove and just ignores them and only looks at the proper image that you're trying to log on with the computer. So then eighth place we have finding the object, which is going to be right here. So this is line 28. So after creating the mask, I search for contours. A contour is basically the outline of the detected object. So in a case of a box, the perimeter of the box is going to be the contour. Since I only want the outer boundaries, I'm going to be using this exact thing called um, RETR external. This is what's going to be only using the outer boundaries and nothing else. So that's how we actually lock onto it. So then in ninth place, we have selecting the largest object. So let's say, for example, if you're in a room full of people, full of orange objects, which are very small and are not something you want to be tracking and it'll confuse the entire computer. You want to be able to detect the largest object. So that's where this part comes in. So as you can see, if the program sets any contours, which is, as I said, the boundary, I select the contour with the largest area in this project. The largest orange contour is assumed to be the orange box I want to track. So as I said, if the contours is basically the boundary of the detected object. So this is basically saying what is which object in this entire room has the largest contour, and whatever the largest contour is, I'm going to be detecting that. That's what's helping it not detect random objects with slight orange in it. It's detecting the ones with the largest contour. So now we have filtering out small objects, which is going to be right here. I added a minimum area requirement of 80 pixels. This prevents the tracker from locking on to any tiny orange object or random noise. So as I was saying, this also a type of range. But saying like, okay, this is the minimum requirement. This is the minimum requirement of something to be locked onto. It has to be in 80 pixels, above 80 pixels. It cannot be less than 80 pixels, or else it's going to be defined as noise. It has to be above 80 pixels. As I said, you guys can change a lot of the ranges. These ranges are just up to personal preference. You can change these as you want. So it's this one to change the minimum requirement for it to be defined as something you have to detect. This range right here as for line 17, line 18, line 19 is going to be detecting your HSV. What range is your lower orange and upper orange going to be? And yeah, that's basically the ranges that's in this project. So now 11th is creating the bounding box. So as I showed you guys that the box is the one that's the box around the object that looks like a locking system. So that's what we're creating right now. So once the object is defined, I calculate its bounding rectangle. This gives me the x and y positions of the object as well as width and height. So this is going to be used in find the center of the object. This width and height is going to be used to find the center. And as it showed on the video, there's a crosshair. And using that center of the object, we can also draw the crosshair for that. So let me just repeat the bounding box part. So right here is it's saying that when I calculate, so whatever object there, right? it's calculating a rectangle around it. It's making a rectangle around that object. So basically, you could think of it as someone looking at an object through a camera, and you take a screenshot and you just draw a box around it, a box that perfectly fits, like the object perfectly fits inside that box. That's what the computer is calculating here. So that's very important because we're able to find the x and y coordinates, which in the next part right here is going to be used extremely importantly because we need to find the center of the object to make the crosshair. So using, as I said, using the position, width, and height of the bounding box, I calculate the center coordinates of the object. These coordinates are important because they allow the program to know exactly where the object is located within the camera frame. So as I said again, this raw center is not. Sorry, I didn't say this, but as I said again, the raw center is used to make the crosshair, but the raw center can also be and will be used to make the object tracking much more seamless and actually detect the object with the box. So then for part 13, we have actually creating the crosshair, which is going to be right here. So that's going to be 46 to 51. So I use the center coordinates to draw a crosshair directly over the center of the object. This visually shows the position that the computer is tracking. I think that's very easy to understand because I've already coded the center of the object part. So now it's basically saying, okay, let me just draw a plus sign right where the center of the object is. That's the crosshair part of it. So now we have the locked. That's where it's going to be. So this is just to make it much more. I could say like making it more appealing and making it more like professional and like a military kind of scenario. I wanted to be a little more like cool, like with the whole missile locking system, and that's why I said locked. This is not necessary. You don't need to do this. I thought it would be cool because I felt like I might be. It looks like a I have missile locking, so I just did this lock thing. So actually, for just outside of the actual explanation part, I took inspiration from Jarvis. So you know Jarvis from Iron Man. There's a part of the movie where he can log on to a specific thing, and this exact program comes and shows a bus, and they log onto it and it says locked. So I took like a lot of inspiration from that, and also I took inspiration from missile locking systems and all those things like Iron Dome, which locks on the missiles. But as I said, all those things are so much more advanced. Each one of those things have 8 million lines of code or something to control that. This is a mere 69 lines of code. Sorry, no, 75. So it's basically just inspiration, but as I said, you can change this if you don't want it. I did it because I thought it was cool. And also, this is basically the font. Like I like when I was showing it to some people, they were really confused what this meant. This is basically a font that's in there. As I said, the when I was doing the demo, whatever the font was, that's the Hershey symbolics. So let me actually explain the locked part of this. So that's 60 through 62, I believe. So when the object meets the detection requirements, the program displays the word locked above the bounding box to indicate that the object has been successfully detected. This is not only for the aesthetics part of it, this can also be just used as a indication, okay, well, we're sure this has been locked. This is just a signifying detail. It's not just going to be there the for the giggles. It's just going to be there for actual purpose. It's going to be there for you to. It's just indicating, oh, yeah, this is where I already logged onto this. We're good. Like as I said, it's all imagination, and you can always change this up if you want to. So now we have displaying the camera feed, which is part 15. So CV2 right here. So this is 67. This is line 67. So finally, I displayed the process frame, which shows the live camera feed along with the bounding box, center processor, and tracking status. So that's basically just as I said, sorry, it's displaying the process frame, which is showing all the things that we coded, the crosshair, the box, the text, and everything, like the tracking status, everything. That's basically just saying, okay, let me compile all these things and give it to the user. So now, lastly, these are the most easiest parts. This is just saying, so when you actually run the program, you won't be able to close the tab. And don't worry, it's not a glitch or something. That's just how OpenCV works. So like that, you can just minimize it or just completely close out of it using your bottom bar. Or you can just actually click the key that has been listed, which is escape in my program, and it will completely escape all the tabs and also will destroy all the tabs. Destroy meaning not it's not really too bad. It's just destroying means removing all the tabs, which is going to be easier for the user to instead of minimizing everything. So this was the orange tracker, and as I said, there's a lot of parts where if you're a beginner, you won't really understand these um, sorry, these concepts. And that's why it's really important for you to actually research on your own and learn. But also, if you have any questions, as I said, I really want this. I really want y'all to understand this. And it's. I'm sorry if I went too like if I went like too advanced for some people. I just had to explain this really briefly because I try and make my videos as short as possible, and this is already 15 minutes long. So if I went in detail, it would have been well over 30 minutes, and I don't want those videos like that because I just like keeping them short and simple for my benefit and your benefit. So as I said, if you have any questions, please, I would love to answer them. And if a lot of people have the same comments, or if there's like a really big issue with the code or really complex question, I will and 100% will make a video on it eventually. And as I said, if you do want this code, it's in my GitHub below, which I will link. And also, if you see like random rocket simulators and orbital mechanics sims, I have been quite inactive. This entire project, I just like in March. It's July right now. I did this in March because I was just like really bored and I forgot to make a video on it. And I just made all those orbital mechanics and rocket simulators on my GitHub. I will be making videos on those. I just was like really bored yesterday and just kind of locked in, and I kind of made like a lot of projects, lot of versions. I will be making videos on them, on all the versions and explaining all of them. Those are relatively simple. This isn't a kind of a complex project because it's using computer vision and all that stuff. Those projects will be much simpler. And if you're a beginner, I would not suggest you start with this. I would suggest you start with the rocket simulator that I'm going to be explaining and the orbital mechanics in which I will be publishing and making. So that's basically it for the video, guys. I know this took some time and um, as I said, I'm sorry it took so much time, but I will try and make my video shorter. And please ask questions in the comments. I love when y'all ask questions because I love explaining things. So as I said, I'll be making more videos. I'll be making more videos in the rocket simulators and stuff. So I'll see you in the next one, guys. Thank you.